What's up, guys? Welcome back to Algebra 2, Lesson 2. Today we'll be learning about rational expressions and equations. So today has three main topics that we're going to be learning. And this would be arithmetic with rational expressions, solving rational equations, and graphing rational functions. Okay, let's get started. Okay, so I forgot to label this one, but this would be the first subtopic, and the first subtopic would be reducing rational expressions. And this would be under topic 1, arithmetic with rational expressions. Okay, let's get started. So two rational expressions are said to be equal if they evaluate to the same value for each x value that they're defined by. One way to create an equivalent rational expression to another is to multiply the numerator and denominator by the same expression. So, for example, 5 over x plus 2 times x plus 3 over x plus 3. That's one way to create the equivalent rational expressions. So, what you do is right here. So, 5 times x plus 3 on top, x plus 2 times x plus 3 on the bottom, and this would be your final result. Okay? Another way is to reduce by finding a common factor and canceling them out. So, for example, this is already in factored form, I guess, but if it was like in a raw kind of version, what you have to do, you have to find this part right here. You seen this part? And you have to like take it out from there. And then these would technically be called canceling out. And what you're left with is 9 over x plus 3. A little side note is, in some cases, you will have to factor expression fully to cancel out the terms. So it will not be always given to you like in this form. Sometimes you have to find it by yourself. Or we're going to do 2 examples like that. So right now, pause the video, try these 2 examples out, and we'll get started. Okay, example 1. Simplify 3 times x plus 5 over x plus 2 times x plus 5. You see that this is a common factor of this, so this would cancel out x plus 5, x plus 5. Your final answer will be 3 over x plus 2. Okay, the second one, this is a little bit more complicated. It's one of those ones where you have to find your own like factor version. So 2x plus 8, what would that factor to? If you take out the 2, it would be 2x plus 4. And on the bottom, you see that this is one of those simple problems. It's x plus 4 times x plus 1. And so the common factor you find in this would be x plus 4. So these would cancel out. And this would equal 2 over x plus 1. That would be your final answer. Okay. And a little special problem over here. This would be involve, you'll see. Okay, so try this one out for yourselves, and then we'll get started. Okay, so once again, factor top. X plus 3 times x minus 3 over. Now here's the little tricky part. What would this factor out to be? So if you take out the 3 minus x, and this would not be a factor of any of this, right? So the proper method to solve this is take out the negative as you're factoring. So in this case, let me cross that out. If you take out the negative 3, bam, you can rewrite it so that this would be indefinitely a factor of this. So once again, this will cross out. It will be x plus 3 over minus 3. And that would be your final answer. Okay, moving on. We'll be learning how to multiply these rational expressions. So one way to multiply rational numbers is to multiply the numerators and denominators, then reduce the solution. So example, 22 over 10 times 35 over 21. That would equal 770 over 210. But however, if you do it this way, some teachers may ask you to reduce it fully, and this would be like a little complex, you know. So a shortcut is to factor out each of the numbers in the 2 fractions, then combine and cancel any common factors. So let's see example right here. So it's the same problem, 22 over 10 times 35 over 21. So that would equal 2 times 11 over 2 times 5, this right here. And 7 times 5 over 7 times 3, which is equals this. And since you're multiplying them together, you can treat them as the same fraction. So put them all like above each other and all of them below each other, like this. Just extend the line a little bit, basically. And then from there, you would cancel out the common factors, and you'll be left with 11 over 3. And the reason for you to learn this is that this process is applied to multiplying rational expressions. So let's say you have 11x plus 33 over x squared minus 12 minus, x squared minus x minus 12 times x squared minus 16 over 3x plus 12. And that would factor out to 11 times x plus 3 times x minus 4 times x plus 4 over x minus 4 times x plus 3 times x plus 4. And all these would cancel out. And you'll be left with 11 over 3 as your final answer. Okay, moving on. Next up is dividing rational expressions. It's similar to dividing rational numbers. Rational expressions are divided by multiplying the first fraction by the reciprocal of the second. You may know this as, or I know this as, keep, change, flip. So right here, what you have to do is you set up the problem, right? You flip this over. So like the bottom goes on top, the top goes on the bottom, and you change the sign. So hence KCF. And what you're left with is this, and you just factor them out, and your final answer would be 5 over 3 times x plus 3. Okay. Next up is adding rational expressions. Okay, so adding rational expressions requires finding the lowest common denominator, like rational numbers. So there are 4 situations you need to know about. Situation 1, the expressions already have a common denominator. This is the easiest. So you see right here, x plus 3, common denominator. That means you can add without worrying about anything. So x plus 2 plus x plus 5 over x plus 3. And you'll be left with this, 2x plus 7 over x plus 3. Second situation, one denominator is a multiple of another. So right here, in this example, 2 over x plus 3 plus 3 over 2x plus 6. Now you see, if you multiply this by 2, you would get 2x plus 6. So in this situation, what you have to do is multiply this entire fraction by 2. And what you're left with is 4 over 2x plus 6 plus 3 over 2x plus 6. And then again, common denominator, and just add them. So 7 over 2x plus 6. And then the third situation is that the denominators have no common factor. This is easier, but it's a little bit more complicated. You see that this cannot factor that, and that cannot factor this, you know what I'm saying? So what you have to do is the lowest common denominator you can achieve is when you multiply x plus 1 times x plus 3, and this side by x plus 1. And since you do it on the bottom, you have to do it on the top as well. So, and what you're left with is just this equation, and then you don't need to know the answer, it's just the process. Okay, so the fourth situation, it's considered it's the hardest situation, to be honest. So situation 4, the two denominators share a common factor, but the larger denominator is not a multiple of the smaller one. So, I forgot the parentheses. So let's say right here, you just have random equations. Random problems, right? And the denominator is just completely different. So what you have to do is you have to find the lowest common denominator that would make sense in this case. So you see that x minus 3, x plus 3, x plus 3, x plus 4. So what is this side missing that this side has? Well, you have the x plus 3, you have the x plus 3, but you don't have the x plus 4. So this side, you only have to multiply by x plus 4 on both top and bottom. And this side, you have x plus 3 and x plus 4, but what are you missing from this side? Well, you have x plus 3 already, but you're missing x minus 3. So you have to do that for this one, x minus 3, top and bottom. So you would solve it out, and same process, and you get an answer. Okay. And you got subtracting rational expressions. So it is exactly the same as adding. They have 4 situations, once again. But in this case, you have to remember, it's really important that you remember to distribute the negative on the numerator. So let's say, let me make one up. You have 2 over x plus 3 minus 3 over 2x plus 6. Convert, right? 4 2x plus 6 minus, oh well, this is not a really good problem actually, I'm sorry, but if it was like 3x plus 6 or something, maybe like that. And basically what you're essentially doing is 4 minus like the parentheses over this. So you always remember you have to distribute this. So yeah, okay, so very important to remember that. And then next one would be simple rational equations. These are ones that already have a common denominator. So it's like when you set them equal to each other, like this. Okay. So 2x plus 5 over x plus 2 times x minus 3 equals 13 over x plus 2 times x minus 3. In this case, you know that I have a common denominator, and since they equal each other, the denominators are exactly the same, they can be ignored. So what you're left with is only the top functions. I mean the top problem right here. So you'll set that as their own problem. 2x plus 5 equals 13, minus 5, 2x equals 8, and x equals 4. And a little extra step, if you have extra times on your test or whatever, you can always plug the answer back in to make sure you got it correct. So x equals 4, you plug it back in here, and these two sides should equal each other. Okay, so let's move on. This would be the exact same one as the other one, but we'll be doing a different method. The method is called cross multiplication. So let's say, let me rewrite it since you can't see it. 2 over x plus 1 equals 4 over x plus 4. In this case, a method, since there's no common denominator, a method will be to multiply the 2 diagonally. So what is diagonal from 2? X plus 4. And x plus 1 diagonal to 4. And then what you're left with is here. 2 times x plus 4 equals 4 times x plus 1. And then you simplify until you get an answer. Once again, this is a pluggable answer to guarantee the answer. So x equals 2, plug it back in, and these two sides should equal each other. Okay, so the next little section would be solving rational equations with multiple terms. Okay, so if the rational equation has more than one term on either side of the equal sign, the terms need to be combined. So a little brief note about this, you should use all the methods that we went over from topic 1. So let me pull up a little topic. Right here. So all the methods that we just learned, arithmetic with rational expressions. Those methods should be used right here. So, example, x minus 1 over x plus 2 plus x over x plus 1 equals 6x plus 5 over x squared plus 3x plus 2. Okay, since you notice that this is adding, you have to find the common denominator between all 3. So, what are you missing here that the other 2 have? Well, the only thing missing, really, is x plus 1. So you just multiply this side by x plus 1. And likewise for this, you're missing x plus 2. So multiply this entire equation, fraction, by x plus 2. And this you can just leave alone, because it got both. And you'll be left like this little weird little thing. You can always, it's pretty easy. Oh, forgot the parentheses. And this will be simplified down to x equals 3. But here's the thing, like if you factor all the way down, you'll be left with this kind of a equation is set to 0, and you will get indefinitely 2 answers for this one. So x equals 3 or x equals -1. in some cases that one of these answers might be false. So it is necessary, I repeat, necessary for you to plug this one in for this type of problem. You have to plug in both answers. So if one of these answers like makes the problem undefined, when the fraction is undefined, then it is a false answer. Okay, so in this case, -1 is a false answer as it leaves the equation undefined. I usually cross them out, put reject, and then circle this one. And that's it. The next one would be rate word problems. So this is like really, it's like you would see this on the SAT math section. So this is pretty simple. It's just the concept. You just have to think about it. So rate word problems. Example 1. Ariana can complete a coding project in 3 hours. Elijah can complete the same coding project in 2 hours. How long would it take them if they work together? So in this case, since Ariana can complete one entire coding project in 3 hours, her rate is that she would do 1/3 of the project completion per hour. Okay, so Elijah, on the other hand, can complete the same coding project in 2 hours. So that means Elijah's rate is 1/2 of the project per hour. So their combined rate would be 1/x project per hour. So this would be a setup for an equation. So 1/2 plus 1/3 equals 1/x. And once again, it's similar to a multiple term kind of thing, like this. You just have to find the common denominator for all. In this case, would be 6x, because it's easily reached by all three. And adding it up and solving the problem, let me just do it for you. That would be 6/5, or 1.2 hours. So their combined rate would be, it would take them 1.2 hours to complete the same coding project. That would be the answer. And then next, we'll be looking at another type of a rate word problem. This is a little bit more complex. It requires a little bit more thinking, but it's fundamentally the same. So let's get started. 2 cars are driving from Washington, D.C. to New York, which is a distance of 300 miles. The first car went 10 miles per hour faster than the second car and got to New York 1 hour sooner. How long did it take each car to get to New York? So 300 on top, x, you should write out like a let statement. Let x equal, the number of hours it takes to get to New York. So 300 over x. So 300 miles over x hours. That would be mph. It's the first car's speed. Since the second car took 1 more hour, x plus 1 is the second car's time. So that would be on the bottom. So 300 over x plus 1. And since it said the first car is 10 miles per hour more than the second, that means this, you have at 10 miles per hour. It's just straight up, just a constant right there. And then once again, you would solve it out, solve for x. X would be 5 hours, that would be the first car. And then you plug it back in for x plus 1, because remember it said the first car went to New York and got there 1 hour sooner. So that means the second car got there 1 hour later than the first car. So the second car would take a little bit longer than this one. So x plus 1, plug in 5, that would be 6 hours. So the car took 6 hours to get there. Okay, so moving on, we'll be learning the last little topic of today, which would be graphing rational functions. So I didn't write down the other subtopic where I'll just be doing it on my calculator, so we don't really need it. So there's 2 ways to graph rational functions, right? So like the graph of rational functions like 1 over x minus 2 has 1 or more vertical asymptotes, right? Or horizontal asymptotes. So asymptotes are a line that the graph never touches or crosses. Okay? So for instance, this is like, let's say I mean, yeah, it looks like the graph of 1 over x minus 2, but I didn't label it. So right here, it's like, it looks like a line that just like goes straight between. It looks like it's touching, but it does not. It never touches or crosses. Understand? So no matter how infinitely this goes up, or no how infinitely this one goes down, this will never reach or touch this little line. Okay? It may get really close, but it will never touch. Likewise for this horizontal absolute. Forget my drawing of the graph. It's pretty bad, but you get the same method. And this one right here, the one that goes up and down, is a vertical asymptote. So right here, it's called a horizontal asymptote. Okay? So continuing on, you can graph these for yourself on your own calculator. So for those more complicated expressions or equations or function, my bad, you would require a graphing calculator since it's easier to use. Okay, let me show you how to do it. So turn on, and you go for y equals first, right? And let's say you're trying to go for x minus 5 over x plus 1 times x plus 4. So what you have to do, I like to just do it, x minus 5 over x plus 1 over x plus 4, like that. And next, if you want the graph, zoom 6, and you see what you get. It's kind of this like weird little graph. It's one of the more complicated functions, and so you can see all the things you need. Okay, so there is a different little approach to using this little graphing calculator. It is to check to see if two rational expressions are equivalent using the graphing calculator. So let's say like there's a multiple choice question, you don't have that much time. It asks you to simplify a rational expression and the graph of the original expression. You can like graph them both in the same graph, and then you can compare them. So like you just put in each of the answer choices in one of these, right? Or like you can do it individually. I like to do it individually. It doesn't make me confused. So I graph like 3x plus 4, let's say, over x plus 2. And then minus x minus 2 over x plus 2, like so. And let's say that's the problem that the multiple choice was asking. So simplify this, right? And the multiple choice answers all give you 4 different types of simplified answers, but you know that one has to be right, obviously. So look at the graph. So now you know what it looks like. So keep that graph in mind, and you plug in each of the answer choices. Well, in this case, I'm just gonna go for it straight up because I don't have that much time. Once again, it's the same, and I actually recommend that you actually put both at the same time. Then graph, and same thing. But if you want like more concrete evidence, if you do second table, it gives you the coordinates of each of the functions they put in. So you see that 3, 8 over 3, 5 over 2, they're equal. So the answer must be the one that I just plugged in. Okay, so let's move on. The next little unit using this will be solving the equations that are set equal to each other. So like let's say for example 2 over x plus 1 equals 4 over x plus 4, and they're equal to each other. So likewise you can do cross multiplication, you can do all that stuff, but there is a way to do it with the graphing calculator. So what you have to do is plug in each of the individual functions for y1. So one side of the equation in here, and another side in here. All right. So if you pull up the graph, they'll give you 2 like contradicting graphs, and since the 2 like sides of the equation have to be equal to each other, that means their graphs have to intersect at one point, like, or they have to intersect at a point, and that would be your answer. So you can do your intersect feature of the graph graphing calculator. So that's a little easier way, but I like to cross multiply. But if you're strapped for time, this would be a good strategy to use. Okay. So, and that is it for today. Going over what we learned. Algebra 2, Lesson 2, Rational Expressions and Equations. Topic 1, Arithmetic. Topic 2, Solving. And Topic 3, Graphing. Okay, so stick around for next week. I think we're going to be learning exponential and logarithmic expressions and equations. So that will be the next unit, which will be released in about, I'd say, next Tuesday, around. Yeah, so if you had any questions, feel free to leave a comment. I'll try my best to look at them. So thank you for watching. See you next time.